Hello everyone, welcome to our electronics project SDES, which stands for Safe Directional Evacuation System. Now what we have right here is a blueprint of Phoenix Mall in Pune, Maharashtra. Our aim is to direct the people in the mall to the nearest and the safest exit point in case of a fire emergency. Now in case of a fire, we all know that there's a state of panic among all people. This can cause a situation where a person might run towards the fire and hence face drastic consequences. To avoid this sort of chaotic movement, we have devised here a simple escape plan which can move people to safety as quickly as possible. So, our main objective is to direct people to the nearest exit point and that too away from the fire and not towards the fire. Now, due to the complexity of the structure, we have divided the map into 6 zones. Now, I will demarcate these zones for better understanding. So, this zone right here, this is zone 1 and it has 5 LEDs. This zone has one exit point right here. This exit point is actually within the zone itself, and it also has two shared exit points, one with zone 4 and one with zone 2, which I will demarcate later. Now this zone right here is zone 2, and it only has two shared exit points, one with zone 1 and one with zone 5. Now this zone right here is zone 4, uh, and it has 6 LEDs. It also has one exit point within itself and two shared exit points, one with zone 1 and one with zone 5. Now this zone right here is zone 5 and it has 5 LEDs. This zone also has one exit point within itself and two shared exit points, one with zone 4 and one with zone 2. Now coming to the landlocked zones, which is this zone 3 and zone 6. Now this zone 3 has a total of 8 LEDs, and this zone doesn't actually have absolute exit points because it opens up into several zones. For example, this exit point is opening to zone 1. This exit point is opening to either zone 4 or zone 1, like the common exit, and that's and that way. Similarly, the last zone here is zone 6 and it has 5 LEDs. This zone also opens up into several other zones, just like zone 3. Now, by using several smaller breadboards and bi-directional LEDs, we are able to implement the directional signals by placing them at appropriate positions. You can actually see them by these demarcated blue spots right here, like 1, 2, 3, 4. These are the LED numbers. Now I'll explain the binary encoding for each zone. Here 0 represents no fire and 7 represents don't care. The rest of the zones are represented by the respective binary representation.
Hello everyone, I'm Nitheezkant. I will be explaining the design and implementation of this system. So we have implemented this system by three subparts, three units. So we will have the input logic unit, the zonal intrazone logic unit, and the zonal interzone logic unit. So we will so once when these three units are combined, it will be a very reliable design, and all you need to keep this project all you need to keep this system active is just a power supply. You don't need any Arduino or a running computer 24/7 to keep this active. So once you install it in a mall or a building, you will just need to keep a power supply active for this system to keep running. So now let's see how this works. So there is an input logic unit. So let's see the function of input logic unit. Input logic unit should take inputs from the sensors and it should generate an output which is the number of the zone where there is fire. So it will generate the number of the zone where there is fire and send it to the zonal logic units. So basically, let's say there is fire anywhere in zone 1, then the input logic unit should generate the number 001 and send it to all zones. So all zones will get an input of 001. So if there is fire in zone 6, then it should generate the number 110 and send it to all the zonal logic units. So that's the function of input logic unit. So now then the intrazone logical unit, so zonal intrazone logic unit will work when the fire is in that particular zone itself. So when an input logic unit sends an input to the zonal logic unit, it will check the number. So if the number is, say, let's say we are at the zonal logic unit of 4 and the number detected is 4, that is the fire is in zone 4, then the intrazone logic unit will take precedence and it will operate. But we are in zone 4 and let's say the number received is 2, which is 010. If 010 is received, then it will understand that the fire is not in that zone, and the interzone logic unit will take precedence. So interzone logic unit will take precedence, and whatever output that gives will be sent to the LEDs. So you can see this structure more clearly in this flow chart. So this flow chart has an input unit, and the input units inputs will come from the sensor units. So if you see this implementation here, all across the mall, this is the blueprint of the mall. The black tapes are the blueprint of the mall. So now all across the mall there will be these boards. These boards are directional boards, which will have two directional emergency LEDs. So it will show the direction in which people have to run in case of fire. So, and also it will have a fire sensor. So when the fire sensor detects a fire, it should be sent to the input logic unit. An input logic unit will send that the number of the zone to the zonal logic unit, and in zonal logic unit there will be so the zonal logic units are kept at the side here. If you see this one, and even here, if you can see, these are all the zonal logic units pictures, random pictures. So the zonal logic unit will see whether to activate the intrazone logic subunit or the interzone logic subunit. So whatever based on where the fire is, it will activate either one of these, and then it will send its outputs to the display and sensor unit back. So it will go to the display, and based on which number is being sent, I mean, is it a 0 or 1? Based on that, the LED will glow. So if it sends a 1 to the south direction, then the south direction will glow, and it will send a 0 to the north direction. So in that particular LED, south will glow and north will be blank. Or else if it sends the other way around, it will glow the other way around. So that's how this structure of this circuit works. Now let's understand the implementation of each of these units in little more detail. So let's dive into it. And here, if you see, this is the input logic unit. So input logic unit has 6 inputs and 3 outputs. So this is the logic table for the unit. So if you see, I1, I2 through I6 are the inputs. So what is this I1? I1 is the OR of sensor output of all these five sensors in zone 1. So all these 5 sensors output is ORed, and that is taken as I1. That will be taken as I1. So all the outputs of sensors in zone 2, these 3, will be ORed, and it will be taken as I2. So if any of these sensors are detecting a fire, then I2 will be 1. But if they don't detect a fire, I2 will be 0. So this is how the inputs work. So, and it will have 3 outputs, which are Y2, Y1 and Y0. So these three binary numbers indicate the zone's number where there is fire. So basically, if I1 is 1 and others are don't cares, if I1 is 1, then it should generate 0, 0, 1. If I2 is 1, then it should generate 0, 1, 0. So and so on. So when you take this logics and write the equation for it, you get these equations. The Y2 is equal to I4 plus I5 plus I6, and you can see the other equations also. So this is how these equations work, and this is how these were created. So in the input logic unit, what we do is take OR of sensor input of each zone, and then write the and then also implement these logics which generate the outputs. So these generated outputs are then sent to the zonal logic unit. So now let's check the zonal logic unit. So in zonal logic unit, let's first check the interzone logic unit. So interzone logic unit will receive a number. So interzone logic, this chart that you see here is the interzone logic unit of the of the zone number 1. This is of zone number 2, and this is of zone number 3, and so on, 4, 5, and 6. So we have numbered the LEDs in each zone. So if you see, you have to refer to this map for everything. So in this map, if you see, these are this is the LED number 1, LED number 2, LED number 3, and so on. So for the interzone logic, what we have done is we have the LED we have the LED numbers written here, and the zones fire and the zone in which the fire is detected written here so in the table. So now if you see, let's say the fire is in zone 2, then LED number 1 should show north, LED number 2 should show north, LED number 3 should show south, west, and north. 4 will show west and north. So you can like see that here. How does that happen? So when there is fire in zone 2, in zone 1 it should be showing north, 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 and like this should show this direction, and this also should show north, because we don't want to risk them by sending towards the south. There could be fire in this area also. So that's why it's implemented like this. So now I showed you for one of the things, so you can see this table and understand for all the other zones and all the other LEDs what it should be showing. So this is how it works, and then if you solve the K-map of this, you will get the equations for each of the directions in each of the LEDs. So north direction in LED number 1 will have this coding, which is y1 plus y2 y1 plus y2 y0. So that is because it should show north for 2 and 3, and it should show and it should not show it should not show north for 4. It should show north for 2, 3, 4, 5, and 6. And 7 is set as don't care, and 1 is the zone where fire is there. So that is always set to 0 for both north and south. It is set to 0 in interzone logic unit, because intrazone logic unit should take care when the fire is in zone 1, and zones and 0 is set to is always set 0 in all the zones, because 0 indicates that there is no fire in any zone. So that's how it works. So if you go to the next zone, zone 2, you will see that the column 2 is missing again, because that will be intrazone logic and not the interzone logic. So that's how it works. So you can see all the different equations here, and all these equations are implemented in the circuits. You can see we have implemented all these logics in these circuits here, and then given the outputs to the LEDs through these wires, which goes to the LEDs. So this is how the interzone logic unit works. Intrazone logic unit is pretty straightforward. So like so in intrazone logic unit, if you see here, let's say this area, and if intrazone logic unit is activated, then let's say there was fire in zone 1 and in the unit number 2, then 3 will show south, 4 will show, basically it should diverge away from the fire. So it will always show the all the LEDs will just show the opposite direction. So basically it's a simple OR. So if you let's say if you check the south direction LED for unit 3, then it is 1 or 2. If there is fire in 1 or 2, then south direction will glow. And if you see the north direction in LED 3, then it is 4 or 5. So that's how everything is implemented in these intrazone logic units. So intrazone logic units are simple ORs of the opposite direction. So that's how intrazone logic units are implemented. So now that you have a basic idea of all the logic units, we can see the demonstration, and Shashank will be explaining the demonstration. So we are running the demonstration in unit testing mode, so that we can actually demonstrate you everything. So in unit testing mode, what we will be doing is for interzone logic unit, we will assume that the first we will assume that the fire is in each zone for 30 seconds. So we will tell you first the fire is in zone 1, then zone 2. So we will show you how it works. So we will, instead of giving the input from the input logic unit, we will be giving the input through Arduinos uh, to each of the zonal logic units, so that we can demonstrate you. So for every 30-second delay, we will send different inputs. So first we'll send there are no fires, then we'll send fires in zone 1, and then we'll send all the way to fires in zone 6. So this way, interzone logic unit, we can demonstrate you interzone logic unit. So when we demonstrate you the interzone logic unit, whichever zone has the fire won't glow. The LEDs in that zone won't glow, because that will be intrazone. So interzone logic for that should be 0. So then after demonstrating you the interzone logic unit, we will move on and demonstrate the intrazone logic unit. The intrazone unit testing code for demonstration purposes is like this. If any of the inputs go up, if any of the inputs value for inputs, we are showing through push buttons, because if we are gonna keep fire sensors in a small demonstration map, all the fire sensors will light up when there's a fire, because it has to detect fire for a large area. So for demonstration purposes, we'll show push buttons, and if the push button gets high, that is if the push button gets high, then we will put the code of that zone. So we will be demonstrating you in zone 2. So we will send this is basically the input. So we will send input as 2. So now in zone 2, the intrazone logic unit will be activated. So when intrazone logic unit will be activated, we will press the button and show you based on which sensor goes high what will happen. Or else we will if no sensor goes up, then we have set it to 0. So it is in 0 means there's no fire anywhere. So for demonstration purposes, we have disconnected the input logic unit and instead give the input through the Arduino. So now Shashank will show you the demonstration. Thank you.
So presently you can see that all the LEDs are switched off, which indicates that there is no fire. So after a few seconds, there will be fire in zone 1. So presently there is fire in zone 1, and therefore all the LEDs are switched off. In zone 2, people are directed southwards. In zone 3 also, people are directed southwards. In zone 4 also, people are directed southwards to the nearest exit. In zone 5, people are directed to the nearest exits. In zone 6 also, the people on the right are directed towards the nearest exit, while people on the left are directed southwards. Now moving on to the next zone, you can see that the fire is in zone 2, therefore all the LEDs are switched off. In zone 1, people are directed northwards to the nearest exit northwards. In zone 3, we see that people are directed towards the north. In zone 4 also, people are directed towards the nearest exit. In zone 5, people are directed northwards. Whereas in zone 6, all the people are directed towards the north. Now moving on to zone 3. When there's a fire in zone 3, since zone 3 is a landlocked zone, all the zones except zone 6 will show the nearest exit. As you can see, in zone 1, all people are shown the nearest exit. In zone 2 also they are shown nearest exit. Same goes for zone 4 and also for zone 5. Whereas in zone 6, all the people are directed southwards. Now moving on to the next zone, which is zone 4. So when zone 4 goes on fire, people in zone 1 are directed southwards. In zone 2, they are directed towards the nearest exit. In zone 3, they are all directed southwards. In zone 5 also, they are directed southwards to the nearest exits. And in zone 6, people to the left are directed to the nearest exit, and people in the right are directed towards south. Now moving on to the next zone. If there is fire in zone 5, people in zone 1 will exit from the nearest exit. People in zone 2 will be directed northwards. People in zone 3 are directed towards the nearest exit. People in zone 4 are also directed northwards to the nearest exit, and people in zone 6 are also directed northwards. Now moving on to the last zone, which is zone 6. So since zone 6 is a landlocked zone, all the other zones will show the nearest emergency exits except zone 3. So as you can see, in zone 3 will show northwards. So again, all the LEDs will switch off after a few seconds, which represents no fire. So now we will demonstrate the intrazone logic. So the basic logic behind the intrazone is that we have to diverge people away from the fire. So now when the rightmost sensor goes on, we see that people on the left are shown the left direction, whereas people on right are shown the right. Similarly, when the middle sensor goes on, people on the left are shown the left, whereas people on right are shown right. And when the leftmost sensor goes on, all the people are shown the right direction. Thank you.